In this video, we're going to look at hypothesis testing. We're going to state the null and alternative hypothesis. We'll explain what those are. We're going to describe type 1 and type 2 errors and recognize when they occur and what would happen when that happens. So hypothesis testing involves collecting the data that we've done already from a sample and evaluating the data. Then you, as the statistician, will make a decision as to whether or not there is sufficient evidence based upon the data to reject the null hypothesis. Hypothesis testing consists of two contradictory hypotheses or statements, and a decision is based on the data and the conclusion. To form the hypothesis test, you are going to first figure out two contradictory hypotheses. Collect the sample, kind of like we've done in the homework problems in the lab that we did. We're going to determine the correct distribution to perform the hypothesis test with. We're going to analyze the sample data by performing the calculations that we have been doing up until now, and then we'll decide whether or not we're going to reject or accept the null hypothesis and make some sort of conclusion based on all of this. The actual test begins by considering the two hypotheses. These are called the null hypothesis and the alternative hypothesis. We denote the null hypothesis as H naught. So say we want to show that people who shop online are more likely to have more pairs of shoes. That would be our null hypothesis, that we believe that the people who shop online are going to have more shoes. That could be our null hypothesis. It could be our alternative hypothesis. Now, how do we decide? Well, first of all, the statement about the population hypothesis, if it's the null hypothesis, is always the default to be true. It is always with an equality, whether it is equal, less than or equal to, or greater than or equal to, and we consider that almost the status quo. So the null hypothesis, if we're trying to prove it, then that would be the one that we know has the equality. This is what we believe to be true, and it's usually the status quo. The alternative hypothesis is the one that is never equal, and it has to contradict the null hypothesis. So our null hypothesis about the shoes and online is we'd say, if they shop online 4 or more times a month, we know that they are going to have more shoes. The alternative hypothesis would be, if they shop 4 or more times online, we don't expect them to have more pairs of shoes. So if this is equal, then this would be not equal to. If this is less than or equal to, the alternative hypothesis would be strictly greater than. If the null hypothesis is greater than or equal to, then the alternative is strictly less than. Now, there's a couple things I want you to pay attention to. Some statisticians that write books and write homework problems will use equal in the null hypothesis, even though it should be with a greater than or less than symbol. So just be aware that when you see equal, the other one could be greater than or less than. So just be aware that that happens. I hope I didn't choose homework questions that make that a little more difficult. And then after you determine which hypothesis the sample supports, you make a decision. There are two options: you reject the null hypothesis for the sample because it favors the alternative hypothesis, or you do not reject the null hypothesis for the sample if there's insufficient to reject the null hypothesis. So we're going to have the equality. The parameter is equal to some value, or this is our our null hypothesis. The parameter is greater than or equal to some value. The parameter is less than or equal to some value. What would happen if it's equal, then the would be not equal to, it's greater than or equal to, then it's less than. If it's less than or equal to, then it's greater than. And this tells you the type of test that you're going to need: either a two-tailed test, a left-tailed test, or the right-tailed test. Now, notice the way I always remember it is on the it's pointing to the left. The inequality, the pointing part, is pointing to the left, and the on the inequality on the greater than is pointing to the right. That's how I remember whether or not it's left or right-tailed. Kind of like when we were doing probabilities, and of course two-tailed means that, the not equals to is always two-tailed. So the biggest thing is trying to decide in this part of the homework is what is the null and what is the alternative hypothesis? So you are testing that a mean speed of your cable internet connect is more than 3 megabits per second. Well, that is the ha because it is not greater than or equal to. It is more than, so we know that this is greater than, so that we know that they're giving us the ha or the alternative hypothesis. So we start out with going with doing ho and ha, the null and the alternative. Now, we're saying the mean, so we're going to use mu. So we have mu. Since we know they're giving us the ha, or the alternative, mu is greater than 3, and then we know by default this is less than or equal to 3. The mean entry-level salary of an employee at a company is $58,000. You believe that it is higher. Now, the mean entry level for salary is, so we know this is equal to, so that is my null or ho. So ho and ha. And it's using mean again. So we see mean, so we're going to use mu is equal to that 58,000. Just because we say it's higher to does not mean it is it greater than or less than. Well, we will use the greater than in this case because we believe it's greater than 58,000. We could have used not equal to as well right here. So we could have used mu as not equal to. But because we believe it's higher, we're going to use the greater than. And like I said, that was from up above. Be aware that sometimes this is always equal. This could be greater than or less than. It does not necessarily mean that it's going to be not equal to. Sociology claims the probability that a person is picked at random in the Times Square is 0.83. So we know this is going to be is, see this word is, equal to, so we know this is the null or ho, and you want to test to see if the claim is correct. So the ha would be the not equals to. So ho, this time we're going to use p for proportion, is equal to 0.83, and the ha would be p not equal to 0.83. In a population of fish, approximately 42% are female. A test is conducted to see if in fact the proportion is less. Now, again, this is like this one. This is like B, is that we're going to go with 42%. So if this is proportion, and it means that where this is the ho, proportion is equal to 0.42. The alternative hypothesis is P, we want is less, so we're going to do strictly less than 0.42. So be aware that just because it has equals here does not necessarily mean that you have to use not equals here, and in particular, we really want to make sure it's less than, so we're going to use less than. It does contradict this, but not as strongly as not equal to. Just want you to know that. So that's how we set up the alternative and the null hypothesis. And then we have to talk about the errors that could happen. So when you are conducting your test, your hypothesis tests, you can have two types of failures, which means there are 4 possible outcomes depending on the actual truth or falseness of the null hypothesis and the decision to reject or not to reject. So the null hypothesis is actually true. You don't reject it, so you're good. The null hypothesis is actually true and you reject it. This is a type 1 error. So this is a type 1 error. The null hypothesis is false and you do not reject it. This is a type 2 error. And then, of course, you actually do reject it, and that is the correct outcome. So the type 1 error is that it's true and you reject. The type 2 error is it's false and you fail to reject. Each of these errors has a particular probability. We use alpha and beta to represent these probabilities. Alpha is a probability of a type 1 error, probability of rejecting the null hypothesis when the null hypothesis is true, and beta is a probability of a type 2 error, the probability of not rejecting the null hypothesis when the null hypothesis is false. So in these examples, we're going to state the type 1 and type 2 errors that could happen. The mean price of the mid-sized car in the region is this. A test is conducted to see if this claim is true. So let's start with the ho and the ha. So the ho is the mean price of mu is equal to 32,000. The ha is that mu is not equal to 32,000. So let's talk about the type 1 error. Type 1 error. Type 1 error is the mean price of the mid-size car is really truly 32,000, but we concluded it's not. The type 2 error that could happen is that the mean mid price is not 32,000, and we conclude that it is. So that's the type 1 and type 2. A sleeping bag is tested to withstand the temperatures of 15 degrees Fahrenheit. You think the bag cannot stand these temperatures that low. So the ho is mu is equal to negative 15 degrees Fahrenheit. And your ha would be that mu does not equal the negative 15 degrees Fahrenheit. So there's your ho and ha. So what is the type 1 and what is the type 2? Well, the type 1 would be that it really truly can stand the negative 15 degrees Fahrenheit, but you concluded that it cannot. The type 2 is that it can't withstand, and you concluded that it can. So a group of doctors is deciding whether or not to perform an operation. Suppose the null hypothesis is the surgical procedure will go well. So ho is go well. Ha is that it doesn't go well. So what is my type 1 and what is my type 2? Well, my type 1 would be the procedure goes well. It actually truly does go well, but the doctor doesn't think it did. The type 2 is the procedure does not go well, but the doctor think it did. And the type 2 error actually has greater consequences because the doctor will move forward, assuming that for them it went well. So the type 2 error is actually way worse. Now, last bit, nice short video unlike the last one. The power of a test is 0.981. What is the probability of a type 1 error? Well, we know that probabilities have to add to 1, so we have 1 minus the 0.981. So the probability of a type 1 error is 0.019. So about 2% chance of that happening. So not terribly big chance if you have large numbers, but that means about 2 people in 100 could have a type 2 error if it's, again, going to the surgical procedure. So that's it for this video. We'll talk about more in class, and that's it.